Hello, everyone, and welcome to the Switch Statement Podcast. It's a podcast for investigations into miscellaneous tech topics.
This is episode 3 in our series on Martin Fowler's Refactoring.
Hi, John. How are you doing?
Hey, Matt. I'm doing great. How are you doing?
I'm doing pretty good.
I'm excited to talk about smelly code.
Smelly
one of my
code.
favorite subjects.
Well, this is what's nuts, is this, I think, was the origination of the term. Code smells.
That is insane. I mean, this guy, he deserves a Pulitzer, because has really become a meme.
It is funny.
Everyone uses that phrase.
It's easy to think that these terms just existed forever. There's no creator, what have you, but no.
I mean, the word refactoring itself, right?
I think this was also the popularization of that term. So
it's wild. Yeah, Martin Fowler, dude, deserves some cred.
All right. Well, I think we've spent the requisite amount of time repping Martin Fowler for this episode, so we can actually get into the content of this chapter.
Yeah. He'll send us our fee for promoting his name.
Exactly.
Yeah, let's talk about smells, man. The first one that he mentions is one of my favorites. I think it's the smelliest of all the smells. That's one of the things I wanted to do is talk about how smelly each smell actually was.
The smellometer. We can give our assessment. Do you mind? I always like to take the step back. Got to take that step back.
Yeah. Oh, take a step back, please.
Smells. Can we talk about what a smell is? If someone hasn't, if it's easy to think everyone knows what smells are, but how do you define a smell?
I would define a smell as I'm reading code and I run into code that just feels a little off. It feels like it might be buggy, or it feels like it could be structured in a different way. And it's always a vague feeling, at least for me. Although after this chapter, he puts names to each of these vague feelings, so maybe it'll be easier. But that's kind of how I define smell. It's just this weird, kind of disconcerting feeling that I get when I'm reading code.
Right. I think that's perfectly put. It's not that you have read the code and you know that there's a bug, because that's pretty straightforward.
Yeah.
But it's almost like an uneasiness you get. And it's almost like a sixth sense, a spidey sense that you get after having seen code for a while.
Yes. Yeah, that's a thing. I think this is one, place where senior engineers they just have a more attuned sense of smell. Because I remember when I was a young engineer, I would try to submit code and senior engineers would point stuff out to me, and I just literally would have never noticed it. So I think this is something you pick up over, time in your career.
Right. So so to get back to what you were saying, you had mentioned the smelliest of all the smells, the omega smell. What is that?
Well, I'm not sure what omega smell. I think the first smell that he mentions, which is mysterious name, is one of my favorites. I don't know if it's the smelliest smell, but I think it's up there. It's certainly in the top 3 or 4. Mysterious name, basically, you have a name of a function or class or something in your code that's vague. It just doesn't capture the actual thing. A lot of people will try to be overly brief in programming. I do this myself, and it's a horrible habit. They'll name a variable one letter or something.
Yeah. That's Go's. Isn't that Go's style? Go. Local variables should all be one letter long.
I love Go, but that rule is crazy. I was actually just submitting Go code the other day at work, and someone was telling me change this variable name to AF. And it's I don't know. I understand the reasoning behind that. If you have a variable that's very narrowly scoped, then sure, maybe it makes sense to have a short name. But I don't know. I think some discretion should be applied to that, because it's a scary rule.
It's funny because even in a very short number of lines of code, I think names can become confusing.
Yeah. Oh, absolutely.
There's one part of the mysterious name that I really liked, which is, he says, when you can't think of a good name for something, it's often a sign of a deeper design malaise.
Yes, I'm glad you mentioned that because I love that. I totally forgot about that, to be honest, but
And
I remember.
I 100% agree with it. It's like the resolution isn't necessarily to just come up with this crazy long name. It's like if you need 100 letters to describe what's going on, there's probably another change that needs to be made so that you can find a name that actually works.
Though I am not against really long names. Every once in a while, given, certain circumstances, in order to be clear, you have to have a long name, and that's okay.
And I think that this is the spirit of smells, right? It's like, if it's hard to find a name, maybe that is a signifier that there's a design issue, but maybe not.
Yeah,
and that's because it's not a black and white thing. So,
absolutely. Anyway, I did not want to spend too much time talking about names. I do think it's one of the top smells. Be careful about your naming, people. Name stuff well. It's very important for engineers reading your code. There was only a couple smells that I actually wanted to talk about. He names probably about 25 smells or so. Was there any that were kind of in your top?
Yeah, I had a few that I liked. Or actually some that I disagreed with as well.
Oh, I love that. Yeah, there was a couple that I don't know if I just outright disagreed with any of them, but I definitely, it's scary when you learn rules and you just sort of apply them mindlessly.
Yeah.
Because I think some of these should not be applied mindlessly. You need to use discretion on a lot of these.
So let me talk about one that I do think I kind of disagree with. So he has one here called data class. And he says, data classes are classes that just have fields and getters and setters and nothing else. I wanted to check myself. Is he saying that a data class itself is a smell?
I think that is what he was saying.
Because I fundamentally disagree with that. I think data classes are a perfectly reasonable thing to have literally all over your code base.
Absolutely. And there's even libraries like Proto, which just produces data classes. You can't have logic on a Proto.
Exactly.
So it's a super well-known pattern. I don't understand why he calls it out as a smell.
And this is something we were just talking earlier the other day about data classes, and I almost think I would go far the other direction where if you have entities that are moving around your system that are being passed from one service to another, I almost think there's an imperative to make it a data class. I think that makes much more sense, because otherwise you wind up with this weird translation from these serialized objects that you're being passed around on the wire to this rich class, that you need to hydrate with the object. And I think that causes, there's these unnecessary boundaries where it's like, no, this entity, you should be able to think about this entity in the same way at any point in the system. And you can't do that, especially if you're going through endpoints that are different languages, right? If you have all these methods on them. So
yeah, I mean, that's a super good point. It's like so many systems have layers which literally have different programming languages. You might have a Java server and a TypeScript, front end. And you're not going to be able to reasonably pass these rich objects like you're saying. So data classes are a necessity, and you have to think about what your data classes are and design them so that it makes sense that they're just raw data. Because I did wonder if that's what he meant, because there's a lot of cases where you have a class, this was super common in Java, where you have a class that just has getters and setters, but then you have these services that are kind of constantly calling those getters and setters in order to perform operations, when those operations could just be plopped onto the class themselves.
Interesting.
And sure, in some cases, maybe that's a better design, but to your point, I think data classes are a necessity in a lot of systems. So it's weird to call them out as just a straight smell.
Yeah, I think that's the only one that I got as far as to say I just disagreed that it was a smell at all. But yeah, did you have ones that you?
Yeah, I mean, this is probably controversial, but duplicated code. Now, duplicated code is obviously a smell. If you see code that's literally the same in two different places, that's a smell, and you need to factor it out into a function. But I have seen this happen multiple times, and it's subtle, it's nuanced, but I think it's a misapplication of duplicate code where you have two code blocks that are similar, but there may be some area where they deviate. And one way to fix that is to take those two code blocks, put it into a method, pass some like Boolean into that method, whether to deviate or not.
Right.
And kind of do that. And, I think even in that case, it probably makes sense to factor it out into a single method. But I've seen cases where that gets totally out of hand. And then you wind up with this, in an effort to just fix simple duplicate code where each separate code would just be super simple, you end up creating this crazy, function or service with all this branching logic. And it's a misapplication of duplicate code. And, you can easily make an argument that that's just bad programming. But I think a lot of people will take these rules and, kind of apply them blindly. Like, to use a D&D alignment chart, it's like lawful good versus chaotic good. Lawful good where you're always applying these rules every single time you even see a faint whiff of these smells. I think you need to be chaotic good in programming. Like, you need to follow the spirit of the rules, not kind of the letter of the rules every single time. Temporary field. This is one of my favorite kind of pet smells. Mm-hmm. Basically you write some code and you have like a calculation and you just kind of put it into a temporary field. Mm-hmm. And then later you might use that temporary field. You could just inline the calculation in the place where you use the temporary field. And I highly prefer inlining that stuff. I think temporary fields are, at least what I've seen, one of the largest sources of bugs and mistakes and difficult to read code.
Oh, interesting. Okay, so it's saying, let's because actually I didn't recognize temporary field off the top of my head. So it says there's a field which is set only in certain circumstances on a class. Okay, I didn't realize. I kind of thought you meant like a local variable, but this is more like
which also. Local variable is also a horrible thing. You've probably heard me talk about local variables before.
Right, and I've definitely seen Martin decry their use. But
yes.
But yeah, so this is more like you have a class and you're like, you just, for whatever reason, you're temporarily storing something on that, in that field, and it may or may not actually exist.
Yes. Yeah, the way I've seen it is like, you have some class and it's almost like it's doing two different things. Like, and this is a smell in my opinion, like you have a class that can have two different flavors or like multiple flavors. So you'll have like a set of fields for like flavor 1 and then another set of fields for flavor 2. And, depending on what flavor it is, those fields can be set or not set. And
it's interesting because I guess you could imagine something like a multi-step operation where like you call step 1 in a series and then you set this temporary field and then you call function 2 and then it expects temporary field to exist and be set and uses it and then maybe it unsets it. But it seems like you're just asking to call them out of order or it just feels like a foot gun.
Yeah, totally. It's very easy to misuse something like that.
One other one that I wanted to talk about that I feel like comes up all of the time or just regularly comes up, which I don't think there are easy resolutions to it, but it's the one that's called shotgun surgery, which I thought was just a very visceral name for the smell. But the idea is whenever you're doing thing X, you need to make a one-line change in like 7 different places. It just shows that the code is poorly organized. Like you should have some, potentially introduce some class that represents those separate responsibilities.
Yeah.
And then that thing can, you can always get that class for whatever, in the different contexts and just rely upon that. But yeah, that was another good one that I feel like I see a lot. But sometimes it's not straightforward and like, you just got to change the switch statement in the 10 different places. And
yeah. Oh, speaking of which, he mentions switch statements, which I find slightly controversial because I'm a huge fan of switch statements. But yeah, shotgun surgery is something that I have definitely seen in practice, in actual like professional coding, happen time and time again.
This is something so there's another app that we worked on called Brain Explorer. And there's a little bit of tension in the Brain Explorer code base, I feel, with there's two kind of patterns that happen in different places. So to take a step back, and hopefully this divergence doesn't take too long, but in Brain Explorer, there are several different games you can play. And so for one particular type of game, sometimes you need to show the name of the game. Sometimes you need to calculate the score of the game. And so there's just this set of responsibilities that any game needs to implement so that it can be shown in the various surfaces of the app. And so, I saw this and I was trying to avoid the shotgun surgery, and I created this task presenter class, which the idea is like it just encapsulates all those responsibilities. So when you're adding a new game, you're like, okay, I know I'm going to need to implement these things, and once I have all of those things, this should be well behaved. We should be able to supply the contract for any particular task. But there's also other places in the code where we just have a function which accepts a task type and then switches on the task type and then like does something else. And so I feel like we didn't quite get as far as fully avoiding the shotgun surgery in that case.
Yeah, I mean, maybe this could be a good exercise for us, is to try to like encapsulate all of that stuff inside of that task presenter thing.
It's interesting though, because I think it's a trade-off, because it's easy to implement the function for all of the classes, for all of the different task types, just right out of the gate.
Yeah.
But the other one is easier if you need to create a new task, right? It's like then you see all of the, the contract you need to provide. So it's almost like maybe you should be optimizing for which operation is more regular. Like, are you adding tasks more, or are you expanding the responsibility of a task more? Because depending on which one you're doing more, it seems like, because otherwise then you need to go through this crazy task hierarchy and add all of these different, make all these tiny different implementations in all these different files. And maybe that's less efficient. So,
right. It's definitely a trade-off, because, he talks about switch statements, and he's basically says that switch statements are bad. It's kind of a case where you should have created an object, and you should have like concrete implementations of all of your, basically, every item in your switch statement should have some matching concrete implementation that just has a function. So each case block would just be like a one-liner in like a concrete implementation.
Right.
And I think that works really, really well for certain things. But I also think I have also found switch statements to be really valuable for a lot of cases. You might not want to create a concrete class for like every item, in this like enumeration.
Yeah.
So I think it's one of those things where you just have to use discretion.
I think it is important to keep in mind that Martin Fowler does seem to be coming from a very object-oriented frame. Like, yes. He's very like object-oriented focused, or like object-oriented in a way.
Absolutely, yeah. I think he's like a zealot for object-oriented programming, which is great. I mean, I think object-oriented programming is super useful. It's a tool in the tool chest.
Yeah.
But my personal style is very much data and functions. You know, I'm kind of minimal on creating objects. And, you know, maybe I'm just a terrible programmer, but I think there's just trade-offs.
Yeah.
So it's just, you got to think, that's one thing that I found is so true in programming. There are no hard and fast rules. You literally have to think about every situation every single time.
Yeah. All right. Well, you said you had teased a new smell. So lay it on us.
So I created a few smells, and, you know, maybe he mentions them and I just kind of missed it, but super smart code as a smell. And, you know, I a lot of people talk about this, like some engineers, I would say especially young engineers, try to write code that's like very smart. You know, usually you're trying to minimize the number of lines. So maybe you're using some, you know, crazy like Boolean anding or something in order to achieve some like, you know, I don't even know. I can't think of a good example off at the top of my head, but you end up writing code that's just like impenetrable to the reader.
It's like they're playing code golf. They're code golfing with their production code. And I think it comes from wanting to prove yourself. And it's like, oh, everyone's going to be really impressed by how like clever. Like I was able to express this in like a low number of lines, and it's very performant. So everyone's going to be really impressed.
I see that a ton where you're trying to write code that's extremely performant.
Yeah.
You know, like you're trying to avoid iterating over a list twice or something.
Yes. Which
99.9999 more nines % of the time is completely unnecessary.
Especially like two iterations, like linear iterations over a list. It's like, I don't know. I would not think it's like, it's still linear. I'm going to just keep on, you know, get on with my life.
Yeah. No, and even if you write like n squared code, it can be okay sometimes. It all just depends on the situation. Like if you have 30 items in a list, like, write n cubed code. It's not going to matter.
This is something that I'm thinking more and more about is I think it's crucial that engineers understand the domain of data that they're working with, because you have the types, and I think it's really easy to just, you know, take those types out to the crazy maximum of their possible representation. But then it's like, well, does this ever actually happen in the production system? Like, do we ever have a list with 10,000 items in it in production? Like, no. Like, and obviously it is important. Like, you don't want to make the other problem where you do just like do something trivial and like actually, yes, you do have 100,000 elements or what have you. But I think it's better to write the trivial code that's easy to understand, and then optimize once you see that in production people actually want 10,000 of X.
Absolutely, yes.
Than to write some completely impenetrable code that would work for 1 million items when you actually only have max, like users only need 100.
Yeah, no, exactly. And I just think that's something you learn as you do this a lot. Code should be written to be read.
Yes.
That's the number one priority in my mind. And obviously there's cases where you need to write hyper performant code and you might, you know, pull out all your little tricks, but generally speaking, you know, leave those tricks in your bag, stick to the super normal stuff, obey the conventions. Okay, I have a couple other smells that I invented.
Okay, go for it.
These might be more controversial, so maybe more interesting. Eager library.
Okay.
And what I mean by that is you pull in a library just to accomplish some, you know, relatively small task that's, you know, not necessarily the main purpose of the library. I can give an example, like, you know, there's a collections library called Guava. And I think this is like dated at this point, maybe. But anyway, Guava has all these different collection types and algorithms based on collections. Like you can perform, you know, disjoint set operations or I don't know, whatever. And I've seen people pull in Guava for literally just one operation.
Yeah.
And, it's difficult because obviously you don't want to write some like low level set operation code, but it's also, I think sometimes when people pull in an entire library that has a ton of features just for one tiny feature that maybe could be just written in line, I find that to be a smell personally.
What do you see as the downside? Is this like a size of the binary, or does this negatively impact performance?
I think in some cases, I think there's a lot of potential downsides to a library. One is like the system I work on in my professional life has a trillion dependencies, and a lot of times invoking them is actually a call. Like it's actually a network call. I've seen cases where people will pull in a dependency that makes a network call when something could actually be calculated locally. Like I'm trying to think of an example, maybe like changing or doing some filter on an image. There might be a network call you can make to say, hey, do this filter on an image, give me back the filtered image. But there might be another alternative that's like just a library that does it. Like you might be able to see what that dependency is actually doing and just pull in the underlying library, and that would be better in that case. I've also seen cases where it's hard to know what a library is actually doing sometimes. Like you just see some function call into a library that you're not familiar with, that's just doing something that maybe 10 lines of code could accomplish. And me personally, like I would rather just see that 10 lines of code. And I guess there is other, binary size is one of them. If you're pulling in some massive library, could be an issue. So I don't know. I guess it's a lot of different things. And this is definitely a very, you have to really use discretion here. Because if I'm trying to accomplish something, I will often pull in a library to just do one thing. So it's not something that I would apply every time. But I've seen it in the past where, someone's pulling in a library to do something that I think should have just been, done in line, basically.
Yeah, I feel like I'm having a tough time coming up with a simple rule that would describe when you should write it yourself versus when you should pull in the library.
Yeah, and I don't think there is a simple rule. And I should have thought of examples for this because I knew this was going to be controversial.
I think I would say, to your point about premature optimization, I think I would start with the library, and then, once you see, the other thing I think it's important to know is what is the impact of your dependencies. It's like, right. You shouldn't, yes, it's fine, pull in the library, but you should do that understanding what the ramifications of that library are.
Yes. And actually, I just thought of an example that happened in my professional life. We have a library in our system, a dependency that, it does web calls. It's doing a bunch of network calls. And there's actually a new version at Google that does very similar things. And we had this long debate, and I'm not even sure which side of this debate I fall on. I'm just bringing it up because I thought it was interesting. We had this debate to whether we should keep the existing calls in our system, which some of them we have to keep because the new library doesn't do everything that the old library did, and introduce the new dependency for these new calls. So basically we'd have two dependencies that do very similar things, except one is, quote unquote newer, and the other one, it's not deprecated, but it's older. But we could have used the older one to accomplish the new things as well. So it's like the two choices were either to introduce a new dependency to do these new things, or to continue using this old dependency to do the new things. And I was on the side of just continuing to use the old dependency to do the new things. I generally try not to introduce new dependencies, especially if it's like making network calls. existing dependencies are kind of known quantities to me.
Right.
So to me, there's resistance in adding dependencies.
Or there should be some friction. There should be some minimum resistance that you have to overcome in order, to prove to yourself that it's worth actually adding that dependency.
Exactly. So this is kind of a case of this. Anyway, that was definitely a tough one, and I often wind up on either side of that debate, but I think it's something worth thinking about. And I had one more.
All right.
And I called it bad black box.
Okay.
And this is something that happens a lot in my professional life where, Google has tons of APIs where you're constantly pulling in some dependency and you're calling their API. Whenever you have to actually dig into their API to figure out what's actually happening inside their code, I consider that to be a bad black box. Either they should have structured their API in a way that each of those operations that you're trying to learn about are like separate API calls. Of course, there's downsides to that, but it's a naming thing. It might be a mysterious name issue. But I see this all the time where, whenever you pull in a dependency, ideally it should be you should be able to treat it as a black box. And a lot of times you just can't. You got to dig into the code, you got to read it, and I find that frustrating.
All right, I'm proposing a new name for this, which is it's a gray box.
Gray box.
It wants to be a black box, but actually you can't rely on it as a black box. So you need to
Dude, I like that. I like gray box. Although bad black box has the alliteration, and it's also very hard to say 3 times fast.
Right. No, I think that's very true. As an example, I was just reading some code, and we had something in our system called debouncer. And I'll start off by saying I didn't really understand the difference between debouncing and throttling very well myself until relatively recently. But so there's a very important difference between debouncing and throttling, which is that when you're debouncing, when events continue to come in, they continue to delay the execution of whatever subsequent event is. It's like you are going to continue to treat all of these events as, the same single event until they stop happening for some period of time. And that's what a debounce is supposed to be. A throttle is like, okay, let's say these events keep on coming in. After a certain amount of time, you're just going to fire off an event, right? So it's but it doesn't mean that if events keep coming in that you will never send that event. And so this was called a debouncer, but it was really more of a throttler because I was saying or the first thing I thought was okay, if events keep on coming in, this the nature of the system that was going to be using this debouncer was such that there were going to be events that were coming in very frequently. So you could see this event being delayed for much longer than you would want. But actually it was a reasonable thing to do because it actually wasn't debouncing, by at least my understanding of it. And that's a good example where it's I needed to really read through the implementation of this debouncer, and it was delegating to another library, and I needed to understand so it's like 2 black boxes deep that I needed to kind of not intuitive, but deeply understand what they were doing in order to realize that it was just actually a bad name for it, and it was reasonable that we were using it in that circumstance. So
no, that's a good example, and I guess this is very related to mysterious name, but it's just something I see. I mean, in our professional lives, we deal with APIs so often that I feel like it deserves its own name.
All right, well, I did have one last smell that I wanted to call out just because I love the name.
Okay.
It's called Refused Bequest.
Yes. Refused Bequest.
I don't know if this was Martin Fowler or Kent Beck, because apparently they wrote this chapter together. But one of them has just amazing naming skills here. But the idea of a refused bequest is you're kind of extending from some abstract base class, but then you're not accepting some of its implementations. So it's kind of like, it just alludes to the fact that your hierarchy is wrong if you have a subclass which is deciding not to use some of the abstract base classes implementation. Right? It's like,
yes.
Okay, well, that abstract base class apparently is making too many assumptions about what its subclasses are going to need to do. So, but yeah, I just wanted to call that out as a particularly hilarious name.
No, I love this one. And I think it is a good argument for composition over inheritance. Because I guess, I've seen this happen with inheritance trees where you literally have an override of a function that like throws a not implemented exception or something.
Yes, that's the best.
And it's like, oh God, it's just terrible.
All right. I think, obviously there were a trillion other smells that Martin Fowler goes through, so definitely check out this chapter for them all. But I think we can call it Chapter 3 in the bag.
Yeah, that was really fun. I'll see you on the next chapter.
Tune in next week for Chapter 4 testing.
All right, Matt. I will see you next time.
See you next time.